Hello everyone. Today we will discuss about beta functions. In my last video, we have completed gamma functions and some results including some examples. In this video, we are going to discuss about beta functions, some important results and some examples. If you have not seen that video of gamma function, you can check out my playlist and see the video. I hope you all are enjoying my video. It is very informative to you. Okay, now let us start. First, beta function. Beta function is defined as beta mn equals to 0 to 1 x m minus 1 1 minus x n minus 1 dx. See, x, the variables are same here. If we are writing x, we will write x here. If we are writing y, then here also we have to write y. In this condition, mn is greater to 0. Okay. Some important results. Beta function. Beta function is symmetric. Symmetric means beta mn is equals to beta nm. We will prove it. How the beta function is symmetric? Let us see. Beta mn equals to 0 to infinity x m minus 1 1 minus n n minus 1. This is the how beta function is defined. So we are using it here. We are using this result here. Mn is greater than 0. So as you know, you have learned in 12th class 0 to a fx dx equals to 0 to a minus x dx. This is the result of class 12 and we are using this result in this proof. 0 to 1, in place of x we can write 1 minus x m minus 1 as it is 1 minus 1 minus x n minus 1. I hope this is clear. 1 and 1 will cancel. What will left? 0 to 1 x n minus 1 1 minus m n minus 1 n and m is greater than 0. See, m n, so m n m, so we are writing n m is greater than 0. So from this we can see that beta function is symmetric. Again, next, fifth result. Important results we have done. We have done first three results in gamma functions in my earlier video, and this is, we are starting from fifth result. This is the result of beta function. Okay, now fifth result, another definition of beta function. Beta function is also defined as beta mn equals to 0 to infinity x m minus 1 1 plus x m plus n dx, where mn is greater than 0. Beta mn equals to 0 to 1 y m minus 1 1 minus y x n minus 1 dy. How we are getting this? See, as I told you earlier, this is how the beta function is defined, and we will use the same variable. If we are using x, we will be using x here also. If we are writing y, here y will come. If we are using p, so here also we have to write p. In this we are writing y. Okay. Now put y equals to 1 upon x. So dy will be 1 minus 1 upon 1 plus x ka square. Okay, so in place of y we will write 1 plus x. 0 to infinity. Sorry, we will write minus infinity to 0 and 1 plus x. In place of y we are writing 1 plus x m minus 1 power as it is, 1 as it is, minus as it is. In place of y we will write 1 plus x n minus 1, and in place of dy we will put this value. I hope this is clear. And this minus sign will come outside. mn is greater to 0. Okay. Now next 1 upon x plus 1 mn minus 1 m minus 1, we have solved it. We have taken the LCM and solved it. I hope this is clear. Next, what we have done, 0 to infinity x n minus 1 1. See, as you know, when base is same, the powers get added. You must be knowing this. So we are using this result here. If we multiply it, what we will get? X n minus 1 as it is, and here we are writing 1 plus x as it is, because in denominator 1 plus x is there. Okay, m minus 1 plus n minus 1 plus 2. So minus 1 plus 2 will become 0 and we will get m plus n. We are using 9th class result. What is the result? If base is same, then the powers will add. Here base is same 1 plus x and the powers will add m plus 1, m minus 1, n minus 1 plus 2. So we will get n plus m. Okay, so we can write x m minus 1, 1 plus x m plus 1, and what we will get? Mn equals to nm. This is clear to you? Now next, another form of beta function. Now this is trigonometric form of beta function. We are going to prove beta mn equals to 2, 0 to pi by 2 sine m 2m minus 1 theta cos 2n minus 1 theta d theta. As you know, beta function is defined like this. So in place of x we will write sine square theta and dx will be 2 sine theta cos theta d theta. How we are getting this? We have differentiated it. What we will get then in differentiation? We will get 2 sine theta cos theta d theta. Okay, now in place we will write in place of this. See, in place of x we will write sine theta, because x is sine square theta and dx equals to 2 sine theta cos theta d theta. We have put the values in the starting. We have discussed about the basic how beta function is defined. So we have put the values of sine theta and cos theta in that. I hope this is clear to you. Still you have any doubt, you can comment me. Okay, now 7th relation between beta function and gamma function. This is very important. Relation between beta gamma function. See, beta mn equals to factorial m factorial n factorial m plus n. Mn is greater than 0. We are using third result. What is the result? 0 to infinity e minus kx x m minus 1 dx equals to factorial m km. If you have any doubt how we have got this result, you can see my previous video of gamma function. We have discussed this result in that video. Okay, now replacing k by y. In place of k we are writing y. So what we will get? Factorial m. In place of k we are writing y. So ym equals to 0 to infinity e minus yx x m minus 1 dx. So factorial m as it is, this term as it is, and ym will go this side. It is in denominator here, so it will go in multiplication this side. So we can write factorial m e minus y y n minus 1 factorial m is equals to 0 to infinity e minus y 1 plus x y m plus n minus 1 x m minus 1 dx. Now we will integrate it. I hope this is clear. What we have done here? We have multiplied e minus y n minus 1 both side. This is left hand side, this is right hand side. So what we have done in this step? We have multiplied e minus y n minus 1 both side. See, this step is clear, and this side we have multiplied. So if this e minus y x is multiplied by e minus y, so minus y will come outside, 1 plus x will left inside. Okay, now we will integrate both side with respect to with respect to y. We will integrate it with respect to y, taking limits 0 to infinity. So we are doing integration, and after integration we are getting this. Now we will compare. After comparing it, we are getting beta mn. I hope this is clear. I hope this is clear. We have just done the integration, taking the limits 0 to infinity. 0 to infinity we have taken the limits, and after integrating we are getting this result beta mn. Our next result, this is our 8th result. Same type as we have done earlier, same type, just replace 2m minus 1 by p and 2n minus 1 by q. Let me explain it. See, 0 to infinity sin p theta cos q theta d theta. It is given by r p plus 1 upon 2, theta p plus 1 upon 2 factorial q plus 1 upon 2 factorial p plus q plus 2 upon 2. As we know, beta function is in trigonometric form, it is given like this. So in trigonometric function we can write beta function as this. Okay. Now we are replacing 2m minus 1 by p and 2n minus 1 by q. So m can be written as p plus 1 upon 2 and n can be written as q plus 1 upon 2. Okay. So this is replaced by p. So in place of this we can write p. In place of this we can write q. And here m is written as p plus 1 upon 2, n is written as q plus 1 upon 2 and m plus 1 is written like this. I hope now this is clear. Okay. Now putting q equals to 0 in first. This is our first equation. We are putting q equals to 0. So what we will get? We will get 0 to infinity, 0 to pi by 2. Q is 0, and as you know, if the power of any number is 0, that number will become 1. So sin p theta d theta cos 0 theta will become 1. Okay. Now factorial p plus 1 upon 2 factorial 1 upon 2. Here 2 factorial p plus 2 upon 2 because we have put q equals to 0. Again, now p equals to 0. We will put p equals to 0 and get this. We will get this. Why we are writing sin p? Because 0 1 0. Sin 0 is 0 and cos 0 is 1. I hope this is clear now. Now next is duplication formula. Next is duplication formula. You can take the screenshot of it. You can take the screenshot of it. Okay. I hope you like my video. Thank you so much students for liking, sharing and commenting. Thank you so much. If you like my video, you can check out more videos for more information, for more topics of graduation and post graduation and higher class mathematics. Thank you so much.